Okay, we're here for Notes 8A as part of the Math 4 course. And we're going to be playing with dice today, so I thought this was interesting. I told the story in class about going down to a hobby shop in the old Carolina Town Center and being able to buy dice like this at the counter. And it made for interesting math classes. I used to have some. I don't think I do anymore. I think I gave them away. But anyway. All right, today we are going to find out about something called probability distribution. Which is a table which contains all the possible outcomes of an event and their respective probabilities. So you've got not only the different ways that this thing could happen, but also what is the probability of each one happening. That is a probability distribution table. And so before we get into that, let's deal with some basic probability issues that actually stem back to Math 3. That was the basic idea that probability is your favorable group over the total. Like for instance, probability of pulling out a chocolate donut hole out of this group. Well, I'm going to need to know what the total is on the bottom. So 12 plus 10 plus 8 plus 15 equals 45. So if there are 10 chocolates, then I have a 10 out of 45 chance of drawing a chocolate munchkin. Now, glazed or blueberry, anytime that you see or usually means add. So glazed would be 12, blueberry would be 8, 12 plus 8 would be 20 out of the 45. That would be either glazed or blueberry. It doesn't matter which one, just as long as it's one of them. Now, not jelly-filled, there are 15 that are jelly-filled, so if I want to know the ones that are not jelly-filled, I probably just need to subtract, and that would be 30 out of the 45. And then neither chocolate nor glazed, well, that's not the 10 chocolate, that's not the 12 glazed, there are 8 and 15 left. 8 plus 15 is 23 out of the 45. Now, when you're rolling one die, these are the possible outcomes here, 1 through 6. And understand when they mean a fair die, what they're really talking about is a die that has not been tampered with. You hear about casinos and rigged dice. This is dice that have not been rigged, that are fresh out of the package, and they are you have a perfect chance of landing on any one of the 6 numbers. Sometimes what casinos will do is they'll shave one side. The dots are kind of pushed down inside of it. So if they shave one side of it just a little bit to make one side lighter than the other 5, you might not notice. I even saw an episode of CSI where they took the dots out of one side of it and repainted it with lead paint to make it way more on one side. Anyway, you have a 1 out of 6 chance of rolling a 6 because that's the one possible outcome out of the 6. An odd number would be 1 or 3 or 5. So there are 3 out of 6 ways that could happen. A number larger than 4, that would be 5 and 6. So there are 2 ways out of the 6 that could happen. Now, when they talk about rolling at least a 4, that means it's 4 or bigger, and you really got to watch the English language here. 4 or bigger would be any one of those 3, which would be 3 out of 6. And if you ask about at most 4, that's actually 1 or 2 or 3 or 4. At the most, it's 4. So that's 4 out of 6. Sometimes it is helpful to go off to a space and write out the players that are involved in the problem. Sometimes we make less mistakes when we're not trying to juggle this stuff in our head. I'm just saying, this is a place where it happens a lot. People think that they can keep up with stuff in their head, and it's an awful lot to juggle. Writing things down and having a visual example is worth a whole lot. Now, this is when you're rolling 2 dice. And I'll start by saying the chances of rolling the sum of a 7 and the sum of an 8 are not the same thing. Matter of fact, they're definitely different. And I try to, well, I do it by this. I come up with these 2 columns, and your sum could be anywhere from 2, that's the 1 and the 1 together, all the way up to 12. So the sum of these dice could be anywhere between 2 and 12. Now, how many ways could this happen? Look at the 2. There's only one way that that's going to happen. Look at the 3s. 1 and 2, 2 and 1. There's only 2 ways that you can roll a 3. Look at the 4s. 1 and 3, 2 and 2, 3 and 1. There's only 3 ways that that can happen. You can see the pattern that's happening here. And yes, you're right, until you get to 7. Those are 7s. And also, if you'll notice the diagonal pattern happening here with these dice, that's the thing. You know, that's something that should be there. So yeah, it should be increasing as I get closer to the middle, but once I get past the middle, it should start decreasing again. So the sum of a 7, there are 6 ways that could happen. 6 out of, wait a minute now, how many of these are there? It's 6 tall and 6 wide. 1, 2, 3, 4, 5, 6 sets. 1, 2, 3, 4, 5, 6 sets. 6 by 6 is 36. So there are 36 possible outcomes, and there are 6 ways for it to happen as a 7. If you were to add all of these together, they should add up to 36. A sum of a 2 or a 12. Remember, I said that or usually means that you are adding things. There's one way to roll a 2. There's one way to roll a 12. So there's a 2 out of 12 chance, 2 out of 36. Doubles. Now, anybody that plays Monopoly, well, let's leave it there, and let's erase for a second. Doubles would be like 1s or 2s or 3s or 4s or 5s or 6s. There are 6 ways you can roll doubles. I used to play a version of Monopoly where if you rolled a double, you could get another turn right behind it. I'm not sure if that's officially in the rules or not, but that's the way our family played it. All right, a sum of anything but 7. Now, if there are 6 ways of rolling a 7, and I don't want those 6 ways, there must be 30 ways of rolling everything else. I would say that having this chart on the right of the sum and the ways, that is really, really handy for when you start asking about, what's the probability of throwing this or throwing that with dice. All right. Now, the next stop is looking at a deck of cards. Now, I realize that for some students, you just did not grow up around playing cards and, rolling dice and that sort of thing. My family enjoyed lots of games, and so we played everything from poker to canasta. Yeah, my family up in New York loved to play canasta. And, there was hearts and spades and all that kind of stuff. So, I knew my way around a deck of cards. And I also grew up playing a lot of Yahtzee, which involves rolling dice. So I understood a lot about dice at that point. but not everyone had that kind of upbringing. So um, I've spelled out here a deck of cards. This is all of the cards, this is all 52 cards in the deck right here. And I put over on the left side there, black, red, red, black. I did that because some people will print this out on paper and not print in color, and so everything will turn out in shades of gray. And so I did that to emphasize that the diamonds and the hearts are a red suit, and the clubs and the spades are a black suit. Now, two things that we need to understand about ace. Ace is not one. All right. There are some card games which count it as one. As a matter of fact, you play 21, it can either be 1 or 11, whichever helps you. But because we're talking about a standard deck of cards, this is not necessarily the one. Matter of fact, you play poker, and the aces wind up over here bigger than the jack, king, queen, king. Ace actually beats a king. So, we cannot count it as one. So, sometimes when they start asking you, like, the probability of drawing an odd numbered card, ace does not count as one of them. The other thing we need to understand is that these three at the end are called face cards because they have a face, the jack, the queen, the king, they all have a face on them. And so, or at least, with most standard decks, they do anyway. So there are three face cards in each suit. Clubs, diamonds, hearts, spades, those are all suits. So there are three face cards in clubs, 3 in hearts, 3 in diamonds, 3 in spades. So there are 12 face cards altogether. So you need to kind of be able to distinguish when a suit is important and when it is not. In general, if they ask you for how many fives are there? Well, there are 4 of them because you got clubs, diamonds, hearts, spades. There are five. There are 4 fives. Got to say that real carefully. All right, so that's the introduction to the deck of cards. So now we start asking questions. Probability of drawing an ace. Well, there was an ace of clubs, diamonds, hearts, spades. There are 4 of them out of the 52 cards. So that's your probability. And again, remember that probability is favorable over total. A black queen, drawing a black queen out of the deck. Well, there's a queen of clubs and a queen of spades. There are 2 of them, and there are 2 red queens. An even number card. Now, by that, they mean 2, 4, 6, 8, 10. Those exist as cards, and you also have 4 suits of each. They've got all 5 of those in clubs, in diamonds, in hearts, and spades. So 5 times 4 is actually 20 out of the 52 that fit this description. Not a face card. Remember, we said earlier that the jack, queen, king was in all 4 suits, which meant that there were 12 of them altogether. And we want what is not a face card. What we're going to do is we're just going to subtract it from the 52, and there are 40 cards that are not a face card. Okay. All right, all possible outcomes, and you've heard me allude to that several times, that it is helpful to see a list of all of the possible outcomes. The proper name for that is the sample space. Now, you're thinking maybe that by this description, it kind of reminds you of a population. Well, understand that population talks about people that are being studied, right? Whereas a sample space is all of the possible outcomes for an event. We're not talking about a study here, we're talking about an event. And so all the possibilities, the sum of all the possibilities, when you add them all together, on a given event, they should always total 100%. Or if you're dealing with decimals, it would be 1. You know, if you're talking about flipping a coin, that's a 50% chance for heads, 50 for tails. As a decimal, that would be 0.5 and 0.5, which add together to make 1. But that is probably the key new thing that you're learning with this section, is the idea that everybody on the list should add up to 100%. All right, or it's kind of like, remember the old-fashioned Venn diagrams like this, and or is going to be everybody. That is a union. And it's just going to be that place right there, which is going to be an intersection. So or denotes the union of the two sets. For instance, drawing a club or a 7. There are 13 clubs in the deck. There are 4 7s in the deck. Now, the thing we have to watch out for here is that when you think about it, there is some overlap between them. The 7 of clubs is in the group of clubs and is also in the group of 7s. So it just got counted twice, which means that I should be subtracting out the 7 of clubs because it got counted twice. Now, meanwhile, down here, drawing a club and a 7, what we're looking for here is the overlap. All right, where does it occur in both? When is it both a club and a 7? When it's the 7 of clubs. That would be 1 out of 52. That is my attempt at a club. But you have 1 out of 52 chance of drawing both a club and a 7, because the 7 of clubs is the only one that fits that description, and that is the intersection. That is the overlap between the two. And you notice that with the union, we have to watch out for that overlap. If somebody gets counted twice, we have to subtract them out. I'm not going to hit on that real heavy right now, but we'll come back to that idea. Okay, the last few tables. Remember that probability is always the favorable over the total, which means I need the total of these 3 plus 5 plus 2 plus 6 equals 16. And so my fraction for white would be 3 out of 16. For red would be 5 out of 16. Blue would be 2 out of 16. And green would be 6 out of 16. Now, let me pull up on my calculator here. 3 out of 16 as a decimal comes out to 0.185, which as a percentage would be 18.75%. 5/16 comes out to be 31.25%. Meanwhile, 2/16 is 1/8, which is 12.5%. And 6/16 is the same as 3/8, which would be 37.5. And if I add all of those together, well, I'll put it this way, these two together add up to 50%. These two together add up to 50%. And so 50 and 50 make 100%. And life is good. Here we're talking about Finster the weatherman, and he is making a prediction that there is a 35% chance of rain, there is a 25% chance of cloudy weather, and we're left to our own devices for sunny. Well, we know that they're all supposed to add up to 100. So we say, all right, these two guys add up to 60. And when I take 60 away from 100, I get 40 left over. So that all three of these add up to 100%. Okay, here's another one, I believe the last one. And we've got a chart with everybody except for the last one filled in. And so when I add these two together, I get 0.40. When I add those two together, I get 0.30. And so when I add 40 and 30, that's 0.70 plus 0.11 is 0.81. And when I subtract that from 100%, I get 19% left over. And that should finish that.